we're working with equations that have fourth, fifth, or any power, we can use roots to solve those. Just like we'd use a square root to solve an equation with x squared in it, we can use fourth or fifth roots to solve equations with fourth or fifth powers in them. So really, these will be no different than problems we've done in the past. We'll just be using a higher root in these problems. So as people usually can figure out, just by looking at this first problem, they realize that the first step is going to be to divide by 4, because we want to get that x to the fifth power isolated. So we'll divide both sides of this by 4 and end up with x to the fifth equal to 32. And then to get rid of the fifth power, some people struggle with what to say. They try to say take the square root of both sides, and we're definitely not going to take the square root. Some people, they know what to write. They know that that's what they're supposed to write, but they don't know what to call it. We would just call that the fifth root. Some people call it the fifth square root, which is just really weird and wrong. So it's just the fifth root. To get rid of a fifth power, we'll do the fifth root. So that will cancel out, leaving us just with x left over. And then if the answer works out to be a nice, neat integer, great. If not, in our previous video, we agreed we would round to 2 decimal places if we had an irrational answer. The fifth root of 32 is rational. It comes out just to be 2. So if I were to plug in 2 for x and check this the same way I checked anything else, I'd see that 2 is going to be the answer to this. Next up, we have this. It's a slightly different problem. One thing we learned about in our last unit was we never, ever, ever want to distribute that exponent to something like this. We can't do it. It's not allowed. You can't distribute if there's more than one term inside the parentheses. So distributing that fourth power is never going to be allowed. Instead, what I'll do is I'll actually just get rid of that by taking the fourth root. So to get rid of the fourth power, we'll do the fourth root to undo that. What's left behind then is just x minus 3. I don't need the parentheses anymore. And then the fourth root of 21 is definitely not rational. I used a calculator for this ahead of time and found out that the fourth root of 21 was 2.14. Well, I want to pause for a second. I see there's a note at the bottom of my screen for this problem. And it says, don't forget something when the power is even. So anytime we're taking an even root, like in the past we've taken a square root, now we may be taking fourth roots or sixth roots or eighth roots or any kind of root. If you recall, we always had 2 answers when we were working with square roots, and we got those because we always had a plus or minus symbol. So anytime you're doing an even root, and before we only had square roots, but now we have any root, anytime that root that you're doing is even, don't forget the plus or minus sign because you'll get 2 answers. The reason being is if I multiply positive 2.14 times itself 4 times, I'll get 21. If I multiply negative 2.14 times itself 4 times, I'd also get positive 21. So that's why we have a plus or minus symbol. Once I want to finish this then by adding 3, I'm going to have positive 3 once I add that over, and then plus or minus about 2.14. And you know what? Let's go ahead and just do the math and get 2 separate answers rather than leave it like this. So doing 3 plus 2.14, one of my answers is going to be 5.14. And it's not plus or minus 5.14, it's just 5.14. To get my second answer, let's do 3 minus 2.14. And I end up with a second answer of 0.86. So again, make sure you have that plus or minus symbol as soon as you take the square root. If you were to check this, plug both of those values in for x, one at a time of course, and you'll see that they do both work out to be about 21. And for our final example with solving, let's go ahead and take a look at a real-life problem. So we've got this beautiful looking fish, and it turns out that we can use an equation to estimate the weight of a fish based on its length. So there's the equation that some fish scientist, I guess, came up with that relates the length of a fish to its weight. So our fish is telling us that it's about 200 grams, and we want to know how long that fish is going to be. So I've gone ahead and already plugged in 200. Notice that 200 is the weight of the fish, so I plugged the 200 in for W. So that's why I have an equation to solve it. I can't just plug in a number and work this out. I have to actually solve this. So here's the equation I want to work with. Just like we did previously, although with much nastier numbers this time, I'm going to start by getting the length solved for. So I'm going to divide both sides of this equation by 0.0167. Again, use a calculator. That's obviously going to be a much easier way to do this problem. I've worked out my problem ahead of time, so if you need to pause the video to work this out for yourself, go ahead and do that. Once I divided, I had about 11,967.05. left over is equal to L to the third power, the length cubed. Well, to solve this then, to get rid of that cubed, I'm going to take the cube roots of both sides. So I'll take the third root of both sides, and again, using a calculator and pause pause if you need to work this out for yourself if you don't trust me. That length comes out to be about 22.88. And then don't forget a good label. A label is going to be a good way to answer a story problem. The length of the fish in this equation is determined in centimeters, so about 23 centimeters or so should be about how long that fish is.